Hello, this is Professor Urbis White. This is the second portion of quadratic inequalities. The first part, I was just talking about quadratic equations and some nonlinear equations. Make sure you watch that video before you watch this one. Even though I call it quadratic inequalities, it doesn't have to be quadratic. It's more like nonlinear, rational inequalities, and I did cover that in the rational equations section, but I'll just go over it briefly here as well. Okay, the procedure is the same. Move everything on one side so that you have a 0 on the other side. That's very important. And then try to factor and find critical values by setting each factor to 0. Okay? And then you do your number line and you try to figure out what happens to the sign of whatever you have on one side, and then pick the right sign at the end and write everything in either set notation, interval, number line notation. So let's go over that. So this is not a quadratic inequality, but it's a nonlinear inequality, but it is in factor form. It's actually a rational inequality. Since it's related to quadratics somehow and inequalities, I'm covering it here one more time. So the procedure is the same. Make sure you have 0 on one side, and you set each factor to 0. So let's do that. X minus 1 is 0. X minus 3 is 0. X plus 1 is 0. That will give you your critical points. This cannot be 0. I do know that. I'm just trying to find a critical value. I know that this cannot be 0, but I still need to find it. So I get x equals 1 from here, x equals 3 from here, and x equals negative 1 from here. Now I go and I look at what happens to my expression in these regions. You have a 0, and a 1, and a 3, and a negative 1. Okay? So 1 is here, 3 is here, and negative 1, I'll do it with open circle. I know that I cannot have it. So here are your regions. One region, and here's the second region, third region, and the fourth region. I'm going to go and I'm going to test those regions by plugging in the different values for x in those regions. So let's go do it. Let's say I go and I write x equals negative 2 in this region. What I do, I go and I put it in. Negative 2, negative 1, negative 2, negative 3, divided by negative 2 plus 1. What does that give me? I don't have to calculate it. All I need to look at is the numbers, the signs. This one gives you negative, this one gives me negative, and this one gives me negative as well. 3 negatives is going to give me a negative. So it's going to be negative here. Between negative 1 and 1, let's put 0. So let's put that in there. I will get negative 1, negative 3 over 1. Negative, negative, that's a positive. Okay, so that's going to give me a positive. How about this region? Let's put x equals 2. Let's put it in there. So that's going to give me 2 minus 1. 2 minus 3, 2 plus 1. You don't have to calculate it, just look at the signs. This one is a positive, this one is a negative, and this one is a positive. Positive, positive, negative, so that's going to give me a negative answer. How about after here? Let's pick x equals 4. I'll put 4 in the original equation, 4 minus 1, 4 minus 3, 4 plus 1. That will give me a positive, positive, and a positive. The whole thing will give me a positive. So here. Now I look at my original equation. What was my original equation asking? Where is it less than or equal to 0? That means where is it negative or 0? Let's look at it. It's negative 0 here and here. And it's 0 where? When the top is 0. So how do I write that? The equal is going to be just the top. So I need to go from negative infinity. Let's do it in interval notation. Negative infinity 2 all the way to negative 1. And since negative 1 is in the denominator, I do not want the negative 1. Remember, I put that to myself. It has to be a parentheses because I don't want that. Now I'm going to go to here, union. I go 1 to 3. Now, do I want 1? It's in the numerator, and I have equal. Yes, I do. 3, do I want 3? Yes, I do, because it's in the numerator as well. Here's my interval notation. Now, if I write the same thing in the set notation, I'm going to write x such that x is less than negative 1, and I don't want negative 1, so it's less than, or x is between 1 and 3. Between 1 and 3. You see it? And if I do it on number line, this is going to be pretty much how it is. And I have to show number line. Number line is going to be negative 1, 1, and 3. Negative 1 I do not want. To the left, I color that. 1 I do want, black. 3 I do want, black. And here. You see it? You can actually do it a different color if you want. Do a different color here, and then between this and this is closed, and this is open circle. Okay, let's go do another one. This one is kind of interesting because you have to be really, really careful with this one. What was the very first step? I need to have everything on the left and a 0 on the right. Okay, well, let's do that. Here what you have, x minus 1, x plus 3, minus 2. I just subtracted 2 from both sides. Greater than 0. Now what are you going to do? You're going to put in the same denominator, so you have x minus 1 minus 2 times x minus 1 over, okay, oops, what am I doing? X minus 1, I have to put x plus 3 here. And you have x plus 3 here. Do you see it? So it's x minus 1 over x plus 3. Negative 2, I multiply top and bottom by x plus 3. This is what you have. So let's clean up the top. You have x minus 1 minus 2x minus 6. That is equal to x minus 2x, that's negative x. Negative 1, negative 6, that's negative 7. All right, do you see that? Now this is what I'm going to do. What are my critical points? Negative x, negative 7 equals 0. Negative x equals 7. X equals negative 7. The other one is x plus 3 equals 0. X equals negative 3. So it's negative 7 and negative 3. How many regions do I have? Here, here, and here. Now what is it that you don't want? You don't want negative 3, so make sure you take that one out. So let's pick some regions. I'm going to pick something here. Negative 8. Put it in here. This equation is a little easier. So you're gonna go negative 8. Or this one is a little, okay, this one is a little easier. Let's look at this one. Do you see it? I actually reduced it so I can actually see it. So I'm going to have negative, negative, so that's positive 8 minus 7 over negative 8 plus 3, so that's negative 5. So you're going to have a positive on top and negative at the bottom, and that's going to give you a negative. Between negative 7 and negative 3. So let's pick, I don't know, negative 6 to test. All right. For negative 6, I put it in here. Negative, negative, that's positive 6 minus 7 over negative 6 plus 3, so negative 3. That's going to give me a positive. And no, that's not going to give me a positive. That's going to give me a negative on top. And a negative at the bottom, and that's going to give you a positive when you divide. So here you're going to get positive. And to the right, let's pick 0. And let's test that. I put it in here. You're going to get a negative 7 plus 3, and then that's going to give you a negative. So I'm just doing it with the plugging in just different test numbers. So let's go do the interval notation. What did I want to start with? I want it positive. Where is it positive? Right here. So how do I write that? I have to go from negative 7 to negative 3. And do I want negative 7? And that one is on top. Yes, I do want negative. Oh, I do not want negative 7 because you have strictly. So that means open. Do I want negative 3? I don't want that either. Here, interval notation. If you want to write it in set notation, you're going to write x such that x is between negative 7 and negative 3. If you want to write it in number line notation, you're going to have to put negative 7, negative 3, and you have to say, okay, I want it between negative 7, negative 3, and I want to color it that way. So make sure that you pay attention to where the denominator is 0, take those values out. And I did go over those kind of inequalities in the rational expressions and equations module.